Hello, this lesson is about matter and classification of matter. Some of these terms you may be familiar with. Some of them you may have seen in chapter 1 and 2 of your book. So this should be a quick reminder of things that you maybe even learned in middle school. Two things to note is that matter has mass and volume because it's going to be something that is tangible and that can take up space. There are other characteristics of matter that help us to categorize into specific subunits or into specific categories. So the properties that we're going to be talking about later are physical properties like color and chemical properties like is it flammable. So those are two characteristics that we will be talking about in the next lecture. Everything in the universe is matter except for energy. So take a second and think to yourself which of these are matter versus non-matter. All right, if you said air is matter, you are right. It is made up of nitrogen and oxygen and some hydrogen, argon, helium even. There are other gases that exist in the air as well. Even or carbon dioxide is a greenhouse gas. Blood is matter. It even has iron in it. If you know that hemoglobin is important to your body to carry around oxygen, iron is what's in the heme of hemoglobin. Light waves, well, that's energy. That's going to be in our next unit of study. So note that's not matter. Music, those are sound waves. So again, that is not matter. And of course, water, H2O, is made up of hydrogen and oxygen, therefore it is matter. So the two main categories of matter are simply pure substances and mixtures. Now, they do further divide into their subparts. So, for example, pure substances are either things that are made simply are elements, are made up of elements, and in a fixed ratio, those are called compounds. You have this on your printed notes. So, a pure substance differs from a mixture because it has a defined composition. It has to be in a specific ratio, or you know exactly what's in that substance. And most of the time in a pure substance, the pure component means that it's homogeneous, means it's all the same, and that's all the same particles, either all elements or all compounds. So that is different than a mixture because, first of all, a mixture is a physical combination of things, and I'm going to use things really loosely here, but it's a physical combination, whereas a pure substance is a chemical combination, which is what a compound is. Chemically bound is what makes that different than physically kind of attracted to each other. So another contrasting part, we said defined composition, where a mixture is variable composition, meaning it's not set with a specific ratio or with a specific percentage of part 1 and part 2. In the mixture, which you can imagine, a mixture of what? Well, now I'm going to define those things I said earlier. The mixture is usually pure substances mixed together, and these pure substances maintain their own properties whenever they're in there. So I always like to use the example of fruit salad. Fruit salad has cantaloupe and honeydew and grapes and pineapple, and all those things are mixed together, but they still taste like their individual properties or individual taste, meaning they were never changed chemically. All right, so further down, a pure substance can either be classified as an element or a compound. The elements are really easy to identify. It's anything on the periodic table of elements, PTOE, periodic table of elements. So things that you may be familiar with is copper, like copper wires in electricity or in a home. Iron, like we talked about earlier, in the blood. SN is tin. So there are some things that they don't look like they sound, but there's anything from the periodic table. However, things like oxygen that you might be thinking from the periodic table, that exists as O2, which is a diatomic molecule. And so O2 is saying that it's a compound because it's two or more elements together. So a fixed ratio of elements. So O2, there's two oxygens, that's the fixed ratio. More examples would be H2O1. There's an imaginary 1 after that. We don't write it though because it's just kind of silly to write. Na1Cl1, well, there's a 1-to-1 ratio of Na and Cl, which is sodium and chlorine. And there's a 6 to 12 to 6 ratio of carbon to hydrogen to oxygen. So the fixed ratio is talking about these subscripts. So that's the main difference between element and compound, and those are under the heading or the umbrella of pure substances. Mixtures, the two divergent groups, are homogeneous mixtures and heterogeneous mixtures. So homo or homogeneous means the same or uniform throughout. So salt water, if you look at salt water, you definitely cannot tell that it is salt water. It looks the same all the way through. You can't tell it's a mixture of ions and water because it looks the same throughout. Different phases or different sections of a mixture that you can differentiate, that's really easy to tell with oil and water. So if you have oil up here because it's less dense and it floats on water, you can see the separation, you can see the different phases, and that hetero, which means different, is very visually apparent. And again, those are physically combined together, not chemically. So these chemically combined substances, let's say water, for example, I'm going to change colors here. Water is chemically bound together. H and O are chemically bound together. But we actually can separate them back into their individual components, H2 and O2. We can do that. And so some ways that we need to know that we can separate matter, some of these separation techniques are physical separation methods, whereas other ones are chemical separation methods. So you can see this arrow is taking compounds back to their elemental form. That was my example earlier, water being pulled back, broken, the bonds are broken, so they're pulled back into their individual elements, hydrogen and oxygen. And so the term that specifically references that is the term electrolysis. And so it sounds like electricity is involved. You were right. Electricity helps break those chemical bonds. Some physical separation methods that were in some vocabulary from one of your reading guides are physical separation methods like chromatography, filtration, and distillation. These don't chemically change the substance at all. It just literally, for example, takes the fruit salad from its original fruit salad blend to its individual pieces, so back to its pure pieces, its pure substances. So those are two additional pieces to know. So this is just an exercise. We will actually do this tomorrow. If you would like to go ahead and try yourself, please go ahead and identify which of these are pure substances, and then which ones are mixtures, and then further down, which ones are going to be elements and compounds, and which ones are homo and hetero mixtures. So the last piece are things called particulate diagrams. And so they're supposed to represent these compounds on the very, very, very nano scale, so you can see what they look like. Well, obviously this isn't what they look like, but it gives you an idea of if they're bound together, if they're not bound together, if it's a mixture, if it's not a mixture, and maybe even the state of matter, solid, liquid, or gas, depending on how close they are together. So let's look at some of these, and you will be drawing these later. First off, do you recognize that this is a mixture? And it's a mixture because it has two or more pure substances involved. And that would be this green double thing here and this blue double thing here. Those are two different things, so it has to be a mixture. Now, the blue double thing, like this, let me actually put it in blue. This right here, you can see that it's combined together by a bond between them that's holding them together. So if it's combined by a bond, then I'm going to call that a compound. CMPD is compound for short. The same is true for the green. So the green atom number 1 and atom number 2 are chemically bound together by a bond. That's how they're being held together. And so that's a compound. And so this is a mixture of compounds. Different compounds at that. Forgive my writing, I'm writing with a tablet. Alright, moving right along, let's go over here to the all blue side. And so you're going to see that you have a blue duo, 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 and another blue duo. That means that there's no difference in these substances. So I'm going to say it's not a mixture, it's a pure substance. But what kind of pure substance? Is it just simply an element? Or is it a compound, meaning it's bound together? If you said compound, then you're right, because you can see that they're bound together, which makes them look like a little duo. So further down, it's a little bit complicated. So all the way down here towards the bottom, you see some singletons. Single, 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 single. I'm not going to circle them all. All of those singles are just atoms, and atoms are representing elements from the periodic table. So these are all elements, all these single guys. And then separately, you'll see, again, our friend that's combined together, and that, again, is a compound because it's combined together. So we have two different things. Elements mixed with compounds. Elements mixed with compounds is a mixture. Now, the homogeneous and heterogeneous are a little bit difficult to tell. So I would say that if everything looks equally distributed, like these over here, these are equally distributed, I would say that's a homogeneous look to it. Now, these are not mixtures because they're all the same, but that's just an example to show they're equally distributed. However, this guy over here, you can see 2 or 3 distinct phases or distinct areas, sections. And so that to me looks more heterogeneous simply because it's not the same throughout. So it's different throughout. You've got the black section, the yellow section, another black section. So that might help you determine if it's something, the mixtures are homogeneous or heterogeneous. So those are some more diagrams you want to become familiar with. All right, we're done with section 2.